Welcome to the session on equations and inequalities, simultaneous equations on graphs and number lines. The objectives for this session are to find solutions of equations using graphs and number lines, and complete related exercises without the aid of graphs. If solutions of simultaneous equations exist, then they can be represented graphically. Solutions to a pair of simultaneous equations represent points of intersection of their graphs. Let's take a look at an example. On the same axes, draw the graphs x plus y equals 7 and 2x minus 3y equals minus 6. Using the graph, give the solutions. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. First, produce a sketch of the equations. On your screen, you have x plus y equals 7. Superimpose on this the line 2x minus 3y equals minus 6. The solution is x equals 3, y equals 4, as shown. If we substitute x equals 3 and y equals 4 in equation 1, on the left-hand side we obtain 3 plus 4, which equals 7. And as the right-hand side is 7 as well, we have that the left-hand side equals the right-hand side. Now let's check in the second equation. Substitute x equals 3 and y equals 4 in equation 2. So 2 times 3 from x equals 3 here, and 3 times 4 from y equals 4 here. And 2 times 3 minus 3 times 4 is minus 6. So the left-hand side equals minus 6, and of course the right-hand side equals minus 6 also. And therefore the solution does indeed work for the second equation as well. Now let's take a look at another example, example 2. On the same axes, draw the graphs 2x plus y equals 2 and y equals x squared minus 1. Using the graph, give the solutions. Pause the video and have a go. Press play when you're ready to view the solutions. So let's try solving this. First, sketch the equation 2x plus y equals 2, and then superimpose on this the equation y equals x squared minus 1. As you can see, one of the solutions is x equals 1, y equals 0. Here. And the other solution is minus 3, 8. We substitute x equals 1 and y equals 0 in equation 1 to check that this is indeed a solution. So substituting on the left-hand side in equation 1 gives 2 times 1 for x equals 1 plus y equals 0 equals 2. The left-hand side equals 2, and of course the right-hand side is 2 as well. So the solution is correct for equation 1. Now let's substitute x equals minus 3 and y equals 8 in equation 1. Two times minus 3 for x equals minus 3 plus y equals 8 is 2. So the left-hand side equals 2, and of course the right-hand side is 2 anyway. Therefore, x equals minus 3 and y equals 8 is a correct solution for the first equation. For a check, it would be sufficient to check in just one equation, as we haven't used this in previous calculations, and we've simply read from the graph. Now let's take a look at quadratic and linear equations. The graph of a quadratic and linear equation can either intersect 2 times, or intersect once, or not intersect at all. After substituting and rearranging, use the discriminant to determine the number of points of intersection. So if we have the equation ax squared plus bx plus c equals 0, then if b squared minus 4ac is greater than 0, we have 2 roots. If b squared minus 4ac equals 0, we have 1 real root. And if b squared minus 4ac is less than 0, we have 0 real roots. Now let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So example 3 says, the quadratic kx squared plus 3y plus k minus 6 equals 0 meets the line y equals 3x plus 2 at exactly 1 point for a positive constant k. Find firstly the value of k, and secondly, for this value of k, find the coordinates of this point. So let's solve part A first. We begin by substituting y equals 3x plus 2 in the quadratic equation. Y appears here, so we substitute here. We expand the brackets, and then tidy up, as shown. Now, the question tells us that this equation has a repeated root. Therefore, b squared minus 4ac is equal to 0. So b is equal to 9. And ac equals k times k. So we substitute that in our equation. And now we solve for k. We rearrange the equation to isolate the k. And finally divide by 4 and square root to give us that k is equal to plus or minus 9 over 2. However, since k is a positive constant, k is equal to 9 over 2. Now let's take a look at part B and solve. So from part A we have that k is equal to 9 over 2. Let's substitute the value k equals 9 over 2 in the quadratic to give kx squared plus 9x plus k equals 0 is equivalent to 9 over 2 x squared plus 9x plus 9 over 2 equals 0. We tidy up, divide by 9 and multiply by 2 to obtain x squared plus 2x plus 1 equals 0. And then we factorize. So x plus 1 all squared is equal to 0. This implies that x is equal to minus 1. We can now substitute in y equals 3x plus 2 to give us y equals minus 1. As shown. So the point of intersection is minus 1 for x and minus 1 for y. This brings us to the end of this session. If you have understood its contents, you should be able to find the solutions of equations using graphs and complete related exercises without the aid of graphs. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to it.